Hey, what's up everyone? Today, I'm breaking down one of the most essential concepts in machine learning, cross-validation. If you've ever wondered how to really know if your model is any good, keep watching. Alright, so imagine you've been working hard on a machine learning model. Maybe it predicts house prices, or maybe it tells you if an email is spam. But here's the catch. How do you actually know if the model will work on new data it hasn't seen before? If you only test it on the data you trained it with, the answer can be super misleading. That's where cross-validation comes in. So what is cross-validation? It's a technique that gives you a much more reliable way to test your model's true performance. Instead of splitting your data just once into a training set and a test set, cross-validation splits it up many times, in different ways, so you get a more complete picture. Let's get specific with the most popular version, K-fold cross-validation. Here's how it works. First, you split your whole dataset into K equal parts, which we call folds. So, if you choose K equals 5, you'll have 5 folds. Each fold is like a little slice of your data pie. Now, the magic happens in rounds. For each round, you pick one fold to be the validation set, the slice you'll test on, and the other 4 folds become the training set, the slices you'll train on. You train your model on your training set, just like normal, and then you test it on the validation set you set aside. This gives you a score for round 1. Then, you do it again. In round 2, you pick a different fold to be the validation set, and the others are your training set. Train, test, record your score. You repeat this until every single fold has had a turn as the validation set. So you've done it K times. At the end, you'll have K different scores, one from each round. The last step is simple. Just take the average of those scores. That average is your model's true performance estimate. It's like getting the wisdom of the crowd instead of trusting just one opinion. So why is this way better than a simple train test split? First, it reduces bias. If you do a single train test split, you might get lucky or unlucky, depending on how the data is divided. With K-fold cross-validation, every single data point gets used for both training and validation at some point. It's fair, and it's thorough. Second, it makes the most of your data, especially if you've got a small data set. You don't have to waste any valuable data sitting unused in a test set. And finally, it helps spot overfitting. If your model crushes it on some folds but tanks on others, that's a big red flag. The average score reflects all that instability, giving you a more honest view. So next time you're evaluating a machine learning model, remember cross-validation. It's simple. It's powerful, and it gives you a much better shot at building something that actually works in the real world. Thanks for watching. If you found this helpful, give it a like, and don't forget to subscribe for more clear and simple explanations. See you next time.